Welcome everyone. Today we are going to discuss about fundamental theorems on Riemann integration. So there are two fundamental theorems on integration. The first one is stated like that: if f is continuous on closed interval ab where a and b are two real numbers, then the functions capital Fx defined as integration with limit a to x f of t dt is continuous on the closed interval ab, and the second one is that the capital Fx is differentiable on open interval ab. Since it is differentiable, the calculation for the derivative is given by the formula like this: f dash x is equal the derivative of this integration, which is nothing but the function f of t with the variable x. So your answer is f of x. So this is the simple way to understand the fundamental theorem 1. Next is fundamental theorem 2. In this case, the condition is that function f should be continuous on the closed interval ab, and the capital Fx is an antiderivative of fx. So therefore, the functions f antiderivative you should know to apply the fundamental theorem 2. If you don't know what is the antiderivative, then this theorem is not useful. So assume that if you know the antiderivative of the given function, then the integration of that functions from a to b, where a, b are constant number, is given as f of b minus f of a. Means upper limit f of b minus lower limit at a, the value of the capital F. Capital F is, again repeating, is the antiderivative of the given function f. So let's have some examples for fundamental theorem 1. So first question is here: find the derivative f dash x if fx is equal 3 to x sine to the power 3t dt. So this is the simplest examples we have. Here is the variable x. So we'll just apply the fundamental theorem formula, this one, and we'll get the derivative of the function as sine to the power 3, and t will replace by x. Simple one. Now instead of x, here instead of x, if you have expression of x like x square or x square plus 2x, then how will solve that derivative in such cases? So in these cases you have to little bit tweak the fundamental theorem of calculus, the first fundamental theorem, little bit modified, and then you can solve it. So we are going to discuss with example. So here capital Fx is equal 3 to x square sine to the power 3t dt. Now look on this here. With respect to the previous problem, you have only the differences in the upper limit, which is x square, a function. So we have to solve this one by using this formula. So this is the original formula for the fundamental theorem. Now if you have an expressions in the upper limit, which we denote as here gx, then what you have to do, you have to get the formula like this, and they multiply by the derivative of g. So this is like chain rule, you have to use it. So in this case, what will be our answer? So thus f dash x is equal, so f of gx, so gx is x square, so and f is sine to the power 3t, so which is replaced by g is x square, so sine to the power 3 x square, And then g dash x means derivative of g, which is x square, so derivative of x square. And this will give you answer 2x sine to the power 3 x square. Now, the next question is if the limit is flipping. Earlier, if you recall that fundamental theorem, we need the constant limit in the denominator. Then we can apply the fundamental theorem 1. But in this case, you have here e to the power x is in the down and 3 is on up. We can always flip that limit of integrations by putting a negative sign. So first we will rewrite the function fx for our requirement, that is flip the limit, and then you will get here minus 3 to the power x, remaining is same. So you will apply now derivative, this formula to calculate the derivative, and then you will get it here f dash x is equal sine to the power 3 t, and then t replaced by e to the power x and derivative of e to the power x dx. So it will gives you minus e to the power x sine to the power 3 e to the power x. That's the answer for this question. And the last one is if you do not have the constant on upper limit or lower limit, then how we can solve it? By using the formula of definite integration, we can rewrite the function y as a to x to the power 3 square root of 3t square plus 1 dt minus a to x square 3 square root 3t square plus 1 dt. We divide the interval x square to x to the power 3 in the middle with a constant in such a way that the differentiability and continuity of this function is always intact. So now we separate this integration. So we will get limit a to x to the power 3, and then we will have plus a is upper limit and x square is the lower limit. But we flip it and we got it here minus. So rest is you can apply the fundamental theorem directly and you will get the answer. So in this case we are going to apply this rule, and in our cases here t square in this case will replace by x to the power 3 whole square and derivative of x to the power 3. In this case, t will replace by x square. So it will be 3x square whole square and derivative of x square. And then the last of simplifications, we will have this answer.